Hello again. In an earlier presentation, we talked about the sort of motivation and big picture of the EDA standards. In this presentation, we'll get into a little more detail about how they actually work, what the component standards are, how they work together, and how they fit into an overall communication scheme in a factory. So, first of all, as a reminder, what was different about EDA from the earlier traditional communications? First and foremost is the metadata model, which is a detailed equipment model, which is actually resident in the equipment. That metadata model describes everything that you can collect from the equipment: events, alarms, parameters, state machines, all of that stuff is explicitly defined in the equipment and can be uploaded and used by the client applications. The other big difference was that you can have multiple client applications independently working. You're not restricted to a single point-to-point communication with the equipment. And finally, the data collection demands on the equipment can be defined at any point in time. It's not a fixed scheme. And so any consumer of data can decide that they'd like to have a new data collection strategy, define that in the context of a plan, and have that data sent to them independent of anything else going on. So these are the three big differences between the EDA standards and the prior ones. There are, of course, some other ones that support it, but these are the big three. Now, from an architecture standpoint, the EDA standards don't actually replace the GEM standards. So you can see on the picture here, you have a piece of equipment with multiple potential connections. One is the GEM command and control connection, and that will be the dominant communication interface for command and control information for the foreseeable future. EDA actually complements that capability with a very flexible data on demand kind of capability, and so you'll see the arrow on that is just going north of the equipment. So that is just to support data collection. And there may be other ways to connect to the equipment, but these are the principal ways of getting data off. So let's look at how the actual EDA standards, what they're composed of. You see here in this slide a long list of E numbers. The E numbers are how the semi-standards are defined: E120, E125, E128, et cetera, et cetera. Luckily, you don't have to get lost in those details. There's really only a handful that really matter, and they are the E132, which is the authorization and authentication standard, which is what allows you to actually communicate securely to the equipment. The E120, E125, and E164, these define all of the content and structure of the model. And the E134, which define all the services for actually data collection itself. So these three sets of standards work very closely together. So if you look on this ladder diagram, it's actually a little bit oversimplified because unlike this picture where you have one equipment and one client, you could actually have multiple clients doing exactly the same thing independently. But for simplicity, we've just shown one here. So the first step is to establish a session with the equipment using the E132 set of services. Once you've done that, then you can actually request the equipment to upload the entire contents of the model to you, and these are specified by the E120, E125, and E164 standards. Once you have that model, then you know exactly what's possible to be collected from the equipment. And then you can use the E134 services to define a data collection plan, send that to the equipment to be validated. Once it's valid, then you activate that, and from then on, the equipment is responsible for monitoring the conditions under which you want data to be sent and supplying the data in the form of data collection reports when necessary. So you no longer have to do a request reply for every piece of data. You set up the conditions on the equipment under which you want data to be provided, and it's responsible for then sending that to the consuming clients. Once you're done with a particular session, if you are, then you actually close that session using the E132 services, and the whole data collection sort of life cycle is complete. Now, I mentioned E164, which is the specification for EDA common metadata. This is a very important standard because it explicitly defines the structure, the naming conventions, the required elements that need to be in each model, regardless of the equipment type or vendor. This is important because it enables the host applications to do a great deal of work that can be common to all tool types without having a bunch of custom interface possibilities for each tool. But that standard is a whole other topic because we'll get into the details of that and why it's so important. So we'll save that for a later discussion. Thank you.